Hello, my name is Lonnie Calmes, and I'm the principal investigator for Arete's ONR topic N211-089 program, developing a system we call BOLTS for remote ocean temperature measurement. BOLTS stands for Brillouin Ocean LiDAR Technology System and is based on spectrally resolving Brillouin light scattering from the ocean, which was first theoretically predicted by the French physicist Léon Brillouin in 1914. Arete, founded in 1976, is an employee-owned small business with offices around the United States. Our name is Greek for the concept of excellence, and our employees are known for applying first principles thinking to solve some of the most challenging detection problems for the Department of Defense and the intelligence community. Arete provides state-of-the-art systems and software that are applied from the seafloor to space. BOLTS addresses the challenge of developing and demonstrating a remote measurement system that can spectrally resolve the Brillouin component of backscattered laser light from the ocean and thereby derive a depth profile of ocean temperature and sound velocity. BOLTS will address the Navy's need to obtain high accuracy measurements of temperature, salinity, and sound speed in the upper water column, where acoustic propagation is most effective. BOLTS is targeted for integration into the Navy's MineNet tactical system and into NavAir ASW programs. The system is designed to provide sound speed depth profiles with an accuracy of at least 1.5 meters per second in the uppermost 40 meters of the ocean with depth resolution of 5 meters or less. Currently, the Navy uses conductivity, temperature, and depth, or CTD instruments that must be cast from a surface vessel to produce depth profiles. This process is difficult and time-consuming and provides only a limited number of sample locations. BOLTS will enable remote measurement from either a surface vessel or an aircraft and will produce accurate sound speed maps over a wide sample area and depth. Arete developed a blue-green LiDAR system that measures the Brillouin component of backscattered light at a specific depth by typical time-of-flight LiDAR techniques. Brillouin scattering is an inelastic process, meaning that the scattered light is shifted in frequency from the probe light. This frequency shift corresponds to an exchange of energy with acoustic phonons in the water column. The Brillouin spectrum is a doublet with a frequency shift on both sides of the probe frequency. By measuring the Brillouin frequency shift as well as the line width of the spectrum, the temperature and salinity of the water are uniquely determined. BOLTS accomplishes this measurement by combining a hyperfine spectrometer and a gated intensified CMOS camera, which enables measurement of the Brillouin spectrum in 5-meter depth intervals. The status of the BOLTS program is at the end of the SBIR Phase 2 base period. The system has been modeled, designed, built, and tested in a laboratory environment. Calibration of BOLTS has been achieved over a wide range of temperatures and salinities using a controlled 3-meter cylinder of artificial seawater. Field testing of BOLTS in a seawater tank will occur in the second quarter of fiscal year 2025. In the Phase 2 option period, the BOLTS design will be further ruggedized and optimized for flight testing, and 2 flight tests are planned. BOLTS will provide several advantages and benefits to the Navy, including the ability to perform remote measurement of ocean temperature and salinity to a high degree of accuracy over wide expanses of the ocean, as well as supplying accurate depth profiles of sound speed that can be input to current tactical mine hunting and ASW systems to improve deployment of acoustic sensors and to boost the probability of detection. At the conclusion of the Phase 2 option period, Arete will have a TRL-6 level bolts design that has been validated in real ocean environments. To become an operational system, Phase 3 funding will be required to integrate bolts into current fleet assets, such as the P-8 Poseidon or surface vessels, and to interface with current tactical systems. Arete is searching for a primary transition advocate to advance bolts to TRL-7 and eventually to TRL-8 in fleet operations. In addition to meeting the Navy's operational needs, bolts can also benefit several other agencies and commercial interests, including NASA and NOAA for global ocean temperature mapping and the commercial fishing industry. Arete is seeking relevant program office and prime contractor connections to help transition bolts into the fleet. We are looking for Phase 2.5 or Phase 3 funding to accomplish the packaging, integration, and validation of bolts to the TRL-7 and TRL-8 levels. Thank you for taking your time to learn about Arete and our bolt sensor. For more information about Arete, please visit our website at www.arete.com. If you have further questions about bolts, please contact me or the others listed on this slide. Finally, please stop by our STP booth at the West 2025 exhibit to talk about your needs.